Hello, everybody. Thank you for this opportunity to tell you more about our new migration solution, credativ-pg-migrator. It's a unified offline migration framework for migrating from 7 different databases into Postgres. So let's look at it, what it can do. As the name suggests, I work for a German company called Credativ, and we offer support of open source products. Postgres is one of our biggest topics, and in the scope of what we can offer, we also do these migrations from different systems. And based on previous experiences, I actually decided to create this new solution because existing tools have been always somehow limited. Here are a few words about me. I am originally from Czech Republic, now living 12 years in Berlin. I worked with many different databases, as you can see, and practically almost with all of those which I will talk about today. So I have first-hand experiences with them. Why companies in these days decide to migrate from other system into Postgres? When we talk about proprietary databases like Oracle, Informix, MS SQL, then there is this cost pressure because these companies upgraded their licensing schemas. So typical licensing is per number of core on that machine. Also, support contracts are quite expensive in some cases, and they are pushing for expensive cloud offerings. So in this situation, I have seen some articles showing numbers like only licensing costs per year per databases were much higher, several times higher than salaries of the whole technical team. So in this situation, companies I need to optimize these costs. Uh, Another problem is this vendor locking. These huge companies with proprietary databases, they do not always aim for, optimizing things for customers because their main goal is to optimize profitability. Therefore, mm, there are they have different priorities for changes on in those databases than many of their customers. Another problem are old legacy databases like Sybase Adaptive Server Enterprise, SQL Anywhere. And problem with these databases is that they already do not receive new features. Uh, their feature set are effectively frozen, and vendors who own these databases, they actually focus on those flagship products which they already have in their portfolio. And in many cases, these legacy databases are run on aging infrastructure, sometimes tied to old hardware or old operational systems or older versions of operational systems, meaning security problems, also a limited possibility to actually replace these solutions. And last but not least, there is this knowledge erosion, meaning resources about some of these old databases are slowly disappearing. There could be also misleading information. Experts are also getting quite rare. and original developers and database administrators who actually cared about these solutions in the past, they are already gone from these companies. A lot of stuff is stored in procedures and triggers, and no one really knows how it works, what to do with this. Yet there is a question why we should actually create new migration tool, yet another migration tool, because there are already many open source or commercial solutions. But problem is that these different tools have been always created with some specific use cases in mind, with some specific scenarios. Um, Traditional tools most often support offline migration, meaning we need for migration planned downtime. There are, of course, also CDC-based tools which are able to do online migration with near zero downtime, but from our experience, we can tell that minimum 3/4 of all migrations are offline based, and also companies prefer more these offline solutions because they want to have better control about what is going on that system. Our tool targets these offline solutions, which are most common. But we decided to create a new tool because those existing tools had always some limitations, and it was difficult to communicate with creators of some tools, and some solutions are already not maintained anymore. So therefore, we decided to go our own way. Our credativ-pg-migrator is heavily inspired by PG Loader, which was in past years a quite legendary migration tool, which was designed for heavy enterprise migrations. Unfortunately, in these days, it's not maintained anymore, and we took inspiration as much as possible from this tool, although the latest version was written in common Lisp language, so we could not reuse that code or tweak that code or even take over, and that language is very, very specific. We decided to create our new tool in Python using JDBC or ODBC connectors or native DB connectors. Why Python? Why not some modern sexy language like Rust or Golang? Yeah, well, we tested these languages, and although they are very nice, they have one big problem. They don't care about older databases at all. And I understand it. Those are modern languages. They target modern infrastructure, so they keep compatibility with 2 or 3 latest versions of currently maintained databases, but some older systems, they are really beyond their scope. And here Python is clear winner because it has a very rich ecosystem and libraries which are really proven in production. And also modern Python is completely different language than Python 10 or 15 years ago. This is why we decided to go this way, although it does not look so sexy as saying, "Oh, we have Rust solution." No, we needed to have working solution which would work with whatever strange version of all databases you can imagine. Uh, our tool has modular structure. It's written in classes, and it has those main parts like logger, parser, planner, orchestrator, and parallel workers. Uh, Logger, of course, creates all those entry logs and output. parser parses a config file and creates additional object for migration. Planner reads all metadata from that source database and puts them into protocol tables in Migrator database. And orchestrator takes this metadata prepared by Planner, run parallel workers for different purposes, creation of table, migration of data, creation of indexes, creation of constraints, whatever is necessary. Target database is always Postgres, and we support 7 different source databases: Oracle, Informix, Sybase Adaptive Server Enterprise, SQL Anywhere, IBM DB2 for Linux, Unix, Windows, Microsoft SQL Server, MySQL plus MariaDB, and we also support some special use cases for migration from Postgres to Postgres, although it might sound strange. I will explain in future slides. So basic migration means migration of tables, views, and constraints and indexes. And we can configure like schema only, data only, or both. And for some databases, we also support migration of user-defined functions and triggers. Based on our experiences, we implemented different types of customizations, and because older databases, they allowed all sorts of strange constructs and big freedom in objects and structures, which is not supported anymore. Those proprietary or old databases, they still keep these options for backwards compatibility, but Postgres doesn't. So we need to have options for custom data types transformation, for custom substitution of default values. There is, of course, metrics of substituting old SQL functions with corresponding SQL functions from Postgres, but in some cases we need also custom substitution, so it is also available. Cross-database objects references must be replaced by custom-defined objects, usually some foreign data wrapper which must be created in advance. And we also support selective data migrations, either on time-based filtering or primary key range filtering. There is quite big freedom of defining these conditions. Other features, as I mentioned, for some databases, currently for Informix and Sybase Adaptive Server Enterprise, we have solution for automated conversion of functions, procedures, and triggers. Success rate of code conversion in case of Informix is quite high, 80 to 90%, which is not bad considering differences in SQL syntax. With Sybase, it's currently smaller number. We are still tuning this because Sybase allowed even bigger freedom in formatting the code of these procedures. So it's a more complex task to properly convert them. And you might maybe ask if we tested AI for these transformations. Yes, we did. And it was big fun and also big disaster. Problem is, no matter how prompt is constructed, a large language model does not give stable answers. So if you feed several times the same code into the same language model, there will be always differences. not big in some cases, but unfortunately, it does not work as nicely as we would like to, because of course, if it would work, we would not need to tune some complex regular expressions and some complex manipulations with strings. Common issues with these procedures are some missing objects or renamed columns. This is typical for old applications, that some parts of code in the database are already dead, but usually no one knows about it. Because over time they stopped using some features, those objects are still there, they are unchanged, but uh, over time they implemented some changes into procedures or created new tables or renamed some objects. So yeah, only full migration of the database usually shows what is dead, what is not working. And then they start with this archaeology digging to find some information. We have, of course, some future plans for our migrator. So currently, we are adding automated testing framework for all these databases. It already works very nicely locally. Automatization on GitHub is a slightly different issue, but it's progressing well. We have also some first parts of pre-migration source database analysis because we realized that we always ask the same questions. Like how big is your database? How many tables you have? What are biggest tables? Which tables have biggest amount of indexes? So we are now step by step adding pre-migration analysis for exactly these questions to have answers which we need for tuning of that production migration. We're also working on implementing automatic partitioning into migration, because in old applications, many tables are like huge monolithic objects, either because partitioning did not exist back in those days when application was created, or because for whatever reason developers decided to not use it. So as part of pre-migration analysis, we want also to show some information for those biggest tables and some statistics of data in those tables to actually help customers with these design-related decisions for their new version of application under Postgres. And there are other options which we want to implement, but these are currently our main focus. I mentioned that Migrator allows Postgres to Postgres migration, which may sound like a really bad joke, because there are so many different ways how to migrate data from Postgres to Postgres. Yeah, well, problem is that there are also many discussions on internet of topics like, I dumped my whole database, but I want to restore just one schema. How can I do it from my dump? Or I have these dumps from several different databases, and I want to migrate it all into one database, just into different schemas. With classical dumps, it is not exactly trivial. It can be done with some regular expressions magic, or replacements of strings on fly, but with Migrator, we can simply define these migration sources and targets the way we need them, and it is much more clear what is being done. So this is the reason why we target these very special types of use cases for Postgres to Postgres migration. And now I want to say a few words about those different databases which we support as source databases for migrations. Uh, as I mentioned, I worked almost with all of them for quite a long time. So it is like going back to very well-known adventures. First and most discussed in these days is Oracle because it belongs to most expensive databases. Uh, this is, of course, a pioneering database which actually brought to life many features which are now common in practically all databases. Uh, it was originally created as a CIA project, as we probably all heard, and first public version, first commercial public version was released in 1979. It has many advanced features. Lately, they implemented even AI support, which is accessible directly from database. And this database is closest to Postgres in terms of features and SQL syntax, although that closeness is not as tight as it could look like. We can generally say that Postgres took the best from Oracle, learned from Oracle mistakes, and Postgres also simplified a lot of things. Some, I would say, common, not complicated applications can be migrated from Oracle to Postgres quite easily. Another thing is that there are many very Oracle-specific features, and also SQL syntax of queries is different. So uh, conversion of code or those queries is not trivial and definitely requires manual intervention. Although if we would run some local open source AI, this large language model could be very helpful in these conversions. Informix is another very interesting database, which in these days is still actively developed. New version 15 with interesting improvements was actually released last year in November. And Informix feels almost like Oracle. It has a very similar syntax, very similar structures of objects, and uh, here we support also conversion of functions, procedures, and triggers because generally Informix procedural code is as close to Postgres as you can imagine. It's even closer than from Oracle. For Informix, we can migrate practically the whole application. And because we learned that old systems can have quite severe performance issues, we also support migration of data from unload UNL dump files. You can dump the whole database into those text files, and our migrator can process it. Sybase Adaptive Server Enterprise. This was once very famous database, and it was a leader in implementing many features. Unfortunately, in these days, it's almost dead. It's not actively developed anymore. It is just maintained. Currently, it belongs to sub company. it this database was actually also original source code base for Microsoft SQL Server. It has some special features like tabular data stream. Uh, from our perspective for migration, it is quite simple database. Only issues we have seen were with problems with character sets because although Sybase claims to actually support UTF-16 and convert the data into this character set, we actually witnessed quite the opposite, that all the data still stay in those old character sets, and therefore we sometimes had issues with inserting these records into Postgres, which checks validity of data for UTF-8 character set. Uh, some features are much simpler in a database. Those stored procedures are not full, like full code as we are used from Postgres. They are closer to Postgres SQL functions, not PLPG SQL. And also triggers are quite simple. So a conversion is not so problematic here. Another database, which once looked like having a very bright future, is SQL Anywhere. It was several times required by different owners. Last stable release was published in 2015. This database is practically dead in these days, meaning development and maintenance, but it still runs in many solutions because back in old days, it was a very advanced database with many features similar to current Postgres. And it was used mainly for embedded systems and mobile applications. Yeah, well, in these days, it's fully replaced with SQLite or DuckDB or similar embedded databases. But yeah, we have seen solutions where this database is still running. So this is the reason why we support migration also from this database. IBM DB2, very famous database, which was based on so-called System R project. That System R project is source of SQL language and principles of relational databases. We support version which runs on Linux, Unix, Windows, and there is also version running on ZOS mainframes. But these two products, although they have seemingly the same name, IBM DB2 database, and they are different products with different specific features, and they are also versioned differently and have different code base. So we support this Linux, Unix, Windows version. We have currently one opportunity to try it with ZOS version, although there are very specific problems of getting data from this system. It would be for different talk. Microsoft SQL Server, this is very interesting database developed with, I would say, very nice enthusiasm. It was originally a fork of Sybase Adaptive Server Enterprise back in 1989. but later, at the beginning of new millennia, Microsoft completely rewrote it and implemented it to Windows NT platform. It has many advanced features, very interesting memory optimization options. It also works with vector data types, allows many interesting uh, virtualization. It has also columnar storage for data warehouses. Yeah, only problem is that it is getting also quite expensive with this per CPU core licensing model. So many companies are now facing quite huge licensing payments, and they are asking for support to migrate their applications to Postgres. Uh, Migration from MySQL, Microsoft SQL Server is relatively simple, relatively, and depends on features which you use on original database, because there are some features which require some bigger manual intervention to implement them on Postgres, but everything is doable. Last but not least, MySQL and MariaDB. Uh, this is the database, I think, which everyone from us began with, uh, because when internet started, this was the database which actually made all those interactive web pages and content management systems possible back in end of 1990s and beginning of new millennia. Almost everything was running on MySQL, and many big companies like Facebook still use it, and they implemented a lot of interesting features or created new storage engines. Uh, it is actually the whole environment of different storage engines. So talking about MySQL per se is not simple, because those different storage engines have different features, different limitations, different metadata. So our Migrate supports uh, mainly InnoDB engine, but generally it can migrate data from any engine which has information schema. Uh, In this last part, I want to quickly say what are the main differences between these legacy or proprietary databases and Postgres. It's just a very top-level overview to show what can companies face when they decide to migrate. But again, for everything, there is some solution for implementation in Postgres. One very common occurring problem is that some of these databases have special unique row identifiers, so-called row IDs. Oracle and Informix definitely have them, and back in those days, this identifier sort of replaced primary keys in case when developers did not define primary keys. And unfortunately, we see it quite often that in many applications, tables sometimes don't have primary keys at all, you know. Uh, for migration to Postgres, it is better to think about adding those primary keys, but this is for different talk. Also, these old databases very frequently used synonyms, either for development, for ETL task, or whatever. Those synonyms have been used for several different use cases. We have, of course, replacements for each of these use cases in Postgres. But client must understand that synonyms per se do not exist in Postgres. Uh, they must be always replaced case by case with something else. And there are also very big differences in partitioning. These databases also allowed very different character sets over time. And as I mentioned, they still, in many cases, store data in these old character sets and convert them on fly, which sometimes does not work when we read it from Python libraries. That legacy code also very often enforces strict locking patterns because these databases they usually used redo undo logs and updated data in place. Therefore, in code, they very often use cursor with hold or cursor for update with explicit commits in loops, which is actually not necessary to do the same way in Postgres unless we are talking about some very specific use cases. So some adjustment in code of these procedures is necessary to understand based on use case of that particular code. They have also differences in SQL queries syntax. I think we all have seen those Oracle or Informix select queries which do not use explicit join and on. Simply, people simply put list of tables into from clause, and where clause contains these join conditions. So these things can work in Postgres, but it is better to rewrite them. Also, Informix has special syntax for left outer joins, and some of these uh, databases required pseudo tables for select without source table. So we know this select from dual in Oracle, or IBM DB2 has this select from sysIBM.sysdummy1 table. Very interesting name. And also hierarchical queries are done very differently. They usually implement syntax with connect by prior. It must be rewritten into recursive CTE constructs in Postgres. And some databases like Oracle or Microsoft SQL Server, they allow multiple hints in SQL statements for optimization of its run. Um, Very often they don't have any custom schemas, only owners or very special schema names. There is also quite big fun with identifiers. Theoretically, they allow longer identifiers than Postgres, up to 128 characters. But in old days, these databases had actually limits either to 18 or 30 characters per those names. So we quite often see applications which were created in old versions, so they still have objects fitting into these old limitations. So there is no issue to migrate them into Postgres. If for whatever reason they have newer objects with longer names, Postgres shortens these identifiers to 63 bytes, does not produce any error, just notifies. We so far did not see any issues with names of objects. Some of the databases have higher limits for character large objects or binary large objects or large objects in general. But we must remember also that these databases were created back when disks were much smaller. So we so far did not have any issue with migrating data from these supposedly bigger objects, simply because uh, customers did not have so huge data to store them inside these objects. On the other hand, these old databases usually allowed much smaller text values, these varchar columns, and they were also very benevolent in creating foreign keys between very different data types. So for these reasons, we need to implement some substitutions, and also they allowed primary keys over numeric data types. Postgres is limited to integer or big integer. They have also these procedural languages similar to PL/PG-SQL. These languages with very similar syntax exist practically in all these databases, but they allowed much bigger freedom in formatting, explicit blocks, and they can return either multiple different result sets from a function, or return multiple values from a function. Meaning this must be rewritten into different format, or function divided into two, or whatever. So let's summarize it. Our solution allows to migrate data from 7 different databases. Based on practical production experiences, we implemented many replacements and custom-defined substitutions for data types, default values, remote references, whatever is necessary. We can offer migrations with limitations for data because old databases usually have huge amounts of dead records, which are not necessary anymore, like 20 or more years old records. Those are practically irrelevant for current business. So some customers decide to migrate only living part of the database and only records for, I don't know, last 5, maximum 10 years. Everything older is irrelevant. So if you are interested in using this tool, you can find it on GitHub. We have also a repository on PyPy. Please test it. Please send us issues you find. And if you would be interested in some changes, contact us. We can help, or we can support you in your migrations. So this is all I wanted to show you. Thank you very much for your attention. You can find slides on GitHub and other recorded talks on YouTube. And I will now stop recording.